Okay, I'm back. So I ran a little bit long with my first talk, so I'll steal that time for myself because this is going to be a lot shorter. So I'm just going to give a very quick overview of the software packages that I put together to do the false positive analysis that I explained earlier. And these are really two Python packages called Isochronos and VESPA. And I will talk, they work together. VESPA requires Isochronos, but you could use Isochronos by itself also. Right, so Isochronos is designed to answer roughly this question, and more complicated versions of the same. You have random observations of a star. What kind of star is it? Also note that, I put this together before Gaia DR2, and now we know what all the stars are. So, it's a new world. But you still may want, even with Gaia, might want posterior probability samples of your stellar model. So Isochronos can be used for that too. And this is how Isochronos works. Basically, so first you pip install Isochronos. So this is all using Python, and you define what Isochronos you want. You define a star model with the observations you want, and you fit it. And that's basically it. So you can also just from the command line, if you don't want to work in, at the Python terminal or in a notebook, you can define a config file that where you define what observations you're using to constrain the star, and in the terminal you can say starfit my star, and it does the same thing. This uses it does posterior sampling of the stellar parameters using either MC, so MCMC as implemented by the MC package, or it uses Multinest, which is an implementation of the nested sampling algorithm, which deals better with multimodal posteriors, which is sometimes useful. So in addition to pip installing Isochronos, you might also want to go through the installation procedure for Multinest, which is not a one-liner, but it's relatively straightforward. You can also do things like, spectroscopic parameters, and also a lot more. You can fit this as if it were a binary system. So, you're modeling these photometric observations as if they're the sum of two stars, and you can fit for both stars at once. And you can also, do a lot more. Like, let's say you have, a resolved binary system where the combined brightness of the two stars is measured in like the two mass catalog, but then you have a delta magnitude in one band or another band or two bands or three bands. You can do all that with sort of slightly more complicated INI files for this. So that's, I think, one of the more useful applications of Isochronos, in addition to it being able to enable VESPA. And if anyone's curious about how to do that, I don't have more details here, but come talk to me. I can point you in the right direction. This is just some background. It has another useful feature of Isochronos is you can just kind of pick and choose. You can choose which stellar model grid you want to use. So by default, I think what's included now are the Dartmouth stellar models and the MIST stellar model grids. I've also done, I think another one, I forget what it's called, but it's a relatively straightforward to sort of add any new stellar model grid that you want, and the whole thing works the same. It's just sort of plug and play, so that's fun. So it's a good way to compare results from different stellar model grids to see if there are any differences. Any observable property, you can provide. This is including parallax, so you can input Gaia parallax into this. And I already talked about Multinest and MC, and it has like a prior on metallicity based on sort of local observations from the Sloan Digital Sky Survey. There's a lot of work to do, a lot of the things that I am planning on improving. My actual development of this code has sort of been on hiatus for the last 2 years because I've been like in a different position that didn't really let me work on this very much. But now I'm going back to this. So a lot of these things should be happening relatively soon this coming year. So in particular, when in its current state, the parameterization that Isochronos uses to fit stellar models is in mass, age, and metallicity, and that works fine for like main sequence Kepler stars. But if you start to go to evolved stars, that particular doing interpolation in the mass, age, metallicity space gets pretty messy, which is why these EEP, these equivalent evolutionary point, is sort of a better parameterization to use. And that's all provided in the Dartmouth and NIST models, but it's just not yet incorporated into Isochronos, into the like official release version yet. And some other things that I'm planning on fixing up. And I welcome collaboration and people trying to break it at GitHub, file an issue, submit a pull request, stuff like that. So now VESPA, which is the main focus here, is designed to answer the question, you have a transit signal, what is the probability that it's caused by an astrophysical false positive? First step, pip install VESPA. And then just like you create the same star.ini file, and then you create an additional file called fpp.ini, which is your config file describing the properties of your planet transit. There are a couple different parameters in here that are kind of the results of independent analyses that you need to do outside of VESPA and prior to running a VESPA calculation. And that's the planet star radius ratio, which you can get from doing a fit on your own. And then these two parameters, max rad and sec thresh. Max rad is the sort of maximum radius, angular radius from the target star out to which you're allowed to have a blended false positive, a blended eclipsing binary. And this is in units of arc seconds. And sec thresh is the maximum allowed depth of a potential secondary eclipse in your light curve, because a secondary eclipse can be indicative of a stellar false positive. The lack of secondary eclipse helps you to constrain those false positive scenarios. And so these are things that you need to calculate. These are sort of steps in all of the vetting work that Andrew Vandenberg was talking about in terms of going from pixels to a planet. A lot of those in-between steps are like, checking to make sure that there's no close blended stars, and that you don't have a secondary eclipse, and that the signal is coming from the star that you think it's coming from. All of those things are sort of assumed that you've done that responsibly before turning to VESPA. And once it's set up, you fit a star fit minus all to your planet. Minus all means that you're fitting a single, a binary, and a triple star model to whatever constraints you have in your star.ini. And then you do calc FBP, my planet. And this takes about maybe 25 minutes for a particular candidate. And most of the time is in like fitting the binary and triple star models here. And one of the improvements that I think should be relatively easy to do, and now that I put my mind to it, is making the stellar model fitting much faster in Isochronos, and also thinking of other ways that those models can be defined, just sort of taking the results from Gaia rather than fitting, or at least using them in a different way. If you have the URL to this talk, which will I guess be posted maybe on the website here, you can just look at for example, like these are the VESPA results for any for all of the Kepler candidates that from the DR24 study that I talked about that resulted in the 1,200 planets. If you have a KOI you're interested in, you can just look at what the results look like. Here are the model fits. And the planet parameters and the various false positive scenarios. Kepler FBP.space. This is fun. And right, so this is, yeah, if you want to look at the VESPA results for any KOIs, that's the way to do it. And then for those of you who are not signed up to do group the hands-on sessions, because I know there's limited space, so some of you may not have gotten to sign up. The tutorial is also online at GitHub, and the tutorial notebook that we're going to go through is there. It's linked. And basically what we're going to do in the workshop is, I'll start off first time just kind of running through this together with everybody. So if you can't make the hands-on session, you can run this on your own, and let me know if you have questions. And finally, that's just the link to the code. And what's left here? Right. Okay. So so a few more details on what are the group projects that we're going to go through that you'll have opportunities to work on after we finish going through the tutorials. There are 3 different group projects. The first one is exploring how much do different kinds of follow-up observations contribute to affecting your final false positive probability calculation. So if you have a stellar characterization spectrum, if you have a high resolution adaptive optics image to rule out the presence of close companions, how do those different observations affect the final false positive probability? That's the first project. Then the second and third projects are based on some actually very interesting systems and very good case studies on sort of how to be careful while using VESPA. So there was a study that validated over 100 planets from K2 using the VESPA code. And then there were a couple of papers last year that sort of unvalidated, 6 of them, 3 in each of these papers. And there are various reasons that those unvalidations happened. The first set was because of sort of not being careful in terms of checking where the, making sure that the transit is actually on your host star. And you can do a little bit of exploration into that with project number 2. And project number 3 is even more subtle and exciting, having to do with the sort of stellar properties and how that feeds into calculating false positive probabilities. And so that's a fun one. But the goal of these projects is to sort of learn careful and thoughtful use of VESPA. The fact that you can pip install, create a simple file, and then run it at the command line makes it very easy to use, which is great. But you have to think carefully about what are the actual inputs, before you do that. So one of the reasons that I was able to apply this code to the entire Kepler candidate list was because the Kepler team itself spent years and years and lots and lots of effort doing really, really careful vetting of all of the candidates to turn something into a planet candidate. And so that work was all sort of done on the front end, and then I could come in with VESPA and do the validation calculation and trust that it was reliable. So VESPA is a useful tool, but it's sort of the end of the process, as Andrew's talk described. Oh, right, and then also tests. Several people have talked about sort of the differences between Kepler and tests, and how that might relate to how you might do false positive analysis. So definitely stay tuned for updates related to ways to calculate false positive probabilities using VESPA in the test era. So that's it.
Do you have questions for Tim? VESPA. Nobody? Yes, we're getting tired. Well, wait, this is the hands-on session. So, yes, and this is the hands-on session. So 2 things to note. So for the hands-on session, you don't need to install none of the 2 codes. They're all going to be on the Amazon Web Services. So all you need is the Xterm to access those Amazon Cloud accounts. So no need to do the git install and go to GitHub. That's just at home. If you want to continue with those projects or experiment more, you can install it on your own computer. But for this hands-on sessions, you don't need to install those codes. And also for those of you who were supplying some travel support, we really highly, strongly encourage you to sign up for group projects just to get the most out of this workshop. So that would be really appreciated. So I will put on this table here is general the sign up sheets for XFS and VESPA. There's a 60 people limit for one and the other, so 120 total. And so for now, you just sign up, I want to do an XFS project or I want to do a VESPA project. And then tomorrow, when you go to the hands-on session, you will see sign up sheets for these projects that were explained today, and then you sign up for specific projects. Thanks.
Sorry, one quick thing. There were leftovers from the reception last night, so there's food in the break room across the courtyard. If you'd like that. Oh, I have.
How well can you roast them?
Well, no. Is it rude? This side is that side. If you want to come around this side. Well, you'll be doing those. Yeah. But you're specifically which one? The idea, we're not ready to it. We're already like, well, the develop project with XFAS.